Hey everyone, welcome back. So in the last video we have covered most of the maths problem and there are lots of maths problem are available. So today we are going to move to the next topic, which is array. So from now on we are going to solve most of the problem based on array, and also there will be some containers we are going to use to solve the problems. So our first problem is 2 sum, which is also an easy problem from Leetcode, and it is first question of the Leetcode. Okay, in this case we are going to use array as well as map container. So let's see what is the problem. You have given an array of nums in which you contain values, as well as you have given one more value which is target, which is 9. So our question is, you have to find indexes of two number such that they add up to the target. So basically you can say we have to find two numbers, let's say x plus y, which will be equal to your target. Okay, so if we talk about indexes, let's say this one and this one, this is at the 0th index and this is at the first index. If you do a sum of these number, it will become 9, which is equal to the target. So we have to return these index number, which is 0 1 as a output. Let's take another example. You have array 3 2 4 and you have target 6. So you have to find the index where the values of sum will be equals to 6. So in this case you have 2 and 4 and the indexes are 1 and 2. So our answer will be 1 and 2. So how can we do it? You have array and you have target. You need something like this, right? Because we need two values whose sum will become equals to the target. So one value we can find at ith index and the another value we can find at the jth index. Okay, there is one more condition in the question. I should not be equals to j. That means you cannot pick up same value from the same index. So if you are thinking, if your target equals to 4, and if you are thinking you can pick 0 0 because you have here at 2, it is wrong. So you have to have different indexes. Now we have to do something like this. We can find one value at ith index and we can find value at jth index. So can we iterate over the array and try to sum of all the values? So let's say if we run our ith loop from here and jth loop from here, right? Because we cannot start from the same index. So I am starting j from the next index of the I. If at ith index we have 2, at jth index we have 7. If we do a sum, it will become 9 equals to 9. So we can return our answer from here, right? Let's say we have something like this. In this case, at this index our answer will not be satisfied, so we will move our j. Now 2 plus 11 equals to 22. No, so we will move again and our j will come here. 2 plus 15 equals to 22. No, so our j loops end. Now we will move our I loop, it will come here. Then we will start our j from the next index. Okay, now again we will check 7 plus 11 equals to 22. No, so we will move over j again. Now 7 plus 15 equals to 22. Condition true. So we will return the indexes of these number. It will be 1 comma 3. So in this case we are trying every pairs because we are iterating over at every number and we are trying to find a target. So our code will be something like this. We are solving a problem on Leetcode. So the input will be given in the form of nums and your target will be given. Now let's first declare a variable which will be storing size of array. After that we will run a loop for the ith index. Right now at every I we are running the j. So that means our loop will be nested, because at every I we have to run jth loop. That means it is nested loop. So we will write here for int j equals. Now were we initializing our j from the 0? No, because at this index we are starting our j from the next. If it is I, then it will be I plus 1, because if you start from the 0, every time it will start from this, and we already checked this value, so we don't have to check this value again. So we will start our jth from the next index of the ith. So it will be I plus 1 and it will go till the, and we will check if value at ith plus value of j is equals to target, we can return our index here. So this is our code for the problem. So for every ith, j loop will run and will do a sum of these two numbers and try to match with the target. If it is equals to the target, we can return our answer. Now what is the time complexity? For every ith, we are running j and I is running for the n, j also running for the n. So we can say our time complexity will be n square and space complexity will be big of 1 because we are not using any extra space. Okay, so let's first code this problem, then we will see how we can improve our time complexity. So this is our problem. We are given an integer nums and target, return indices of the two integers such that they add up to the target. You may assume that each input would have exactly one solution. So meaning of this line is there may be a multiple solution, but you can return any of the solution. Okay, so for this we have 9, so at index 0 and index 1 we will get our 9. Similarly for this and this. Okay, so let's write our code, then we will see improved version of this code. So let's first declare our size of the vector. Okay, in this case we are taking a vector, so most of the problem will be taking a vectors. Okay, so now let's write our loop. I equals to 0, I less than n, I plus plus. For int j equals to I plus 1, j less than n, j plus plus. Then we will check value at the ith plus value at the jth is equals to target. We can say we found our indexes, so here we can return our I comma j. Okay, so here you can see return type is vector, so you can create one more vector and store the answer there, or you can directly return the indexes here. Okay, here after for loop we will return 0 comma 0. Okay, here you can see you may assume that each input would exactly have one solution. That means there won't be any example where you can't find your answer. So if you able to find your answer here, it will return from here always. But according to the rules of the programming language, we have to give a return type at the end of the function also. So that's why you can return any random value. So in this case I am returning 0 0, because if you do not return anything at the end of the function, it will give error. Here you can see it wants something return type, so always you have to return something if you are returning answer somewhere here. So the test case is passed. So here you can see our code is working. So time complexity is n square. Now here is a follow-up question. Can you come up with the algorithm that is less than n square time complexity? So we need a algorithm which takes less time than this code. We have array 2, 7, 1, 5 and target equals to 9, and we have written a formula j equals to target. So we have something like this. We know this value because it is given. Here we have two unknowns, right? And using two nested loops we can find both unknowns. But if we want to improve our time complexity, we have to remove one of the loops, right? So if we modify our formula and write something like this, we can remove one of the loops. So in this case we will run a single loop, and that single loop will give me the value for this, and from this formula we can find the value of array of j. So let's see how this will going to work, right? Let's modify a little bit. Let's write like this. This is our unknown equals to target. So we need something here which will make equals to target. For this we are going to use our map, because in map we can find values in a login. So we are at value 2, we will write here 2 dash equals to 9. So here we need something. What we need? If we do a 9 minus 2, it will be a 7. Is 7 is present in the map? No. So we will store our 2 here, because in the future we can use that 2, right? Now let's move to the next value. 7 plus equals to 9. Now here we need a 2. Is 2 is available in the map? Yes. So we can return our indexes. One index is stored here and one index at the current ith. So we can return 0 1. Basically we are saying that the unknown we need is already stored in the map. So in previous iteration we stored our unknown in the map, which we are going to use in the next iteration. Okay, let's take another example. We have something like this, and target equals to 6. And if you write the formula, so if we are at this value, you can write 3 plus unknown equals to 6. So here we need a value. Is there value available which can make it 6? No. So we will insert our 3 comma 0 into the map. Now let's move to the next. 2 plus, we need something which will make 6, which is 4, right? 2 plus 4, but in the map it is available. No, we will insert 2 comma 0. Now let's move to the 4. 4 plus 6, we need something which will make 6, which is 4 plus 2. Is 2 is available? Yes. So we will return 1 this index comma index at this value, which is 2, and this will become our answer. So you can say we are storing previous data so that data can be used in the future iterations. So our time complexity will be, we are running loop which will take big of n, and we are also searching for this value, and for searching this value in the map it will take log n. So our overall time complexity will become big of n log n, which is better than the n square, and our space complexity will become big of n, because we are using map to store our data. But in question it was mentioned that you need a time complexity better than n square, so it is our n log n. Let's write a code. First we will declare a map which will be storing value as well as index, right? Because this 2 was storing index 1, which we were able to return here. So we need to store index also, because you cannot find index later. After that we will write our loop int I equals to 0, I less than n, I plus plus, and now we have to find this value, right? We are talking about finding this value. So this value basically is a array of j equals to target minus array of I, right? So here we will write if mp dot find, because we are finding in the map, what we are finding, target minus array of I not equals to mp dot end. If it is able to find, that means we were able to get our answer. So first index is stored in our target minus nums of I, okay, and our second is stored in the current index itself. Also we will add our values as well as index into the map. So we are running our loop which will be taking care for this iteration, okay, and here we are finding our unknown value in the map. If it is available, we can return our answer, and in the answer we have to return two values. First one is mp of target minus nums. This is a syntax to find the second value of the map, okay, because this one will be a key. Target minus nums I means this one will be the key, right? Because if you do a 6 minus 4, 2, then 2 will become a key, and this key will be used for finding the index. So here target minus nums I, it will become 6 minus 4, 2 will become key, and that key will return a value which will be our index number, and this I is our current index number, right? Because at this position we are at the index number 2, so I is storing the 2 and the another index is stored here. So we will retrieve that index from the map 1 and use this index I equals to 2 to return our answer. So it will become 1 comma 2. Okay, so let's write our code. Declare our map here. After that let's remove this loop and we will find the unknown value into the map. For this we will write find function target minus nums of I not equals to mp dot end. If it is able to find, we can first retrieve the index number from the map, and also we will use our current index to return the answer. Also we will add every values as well as the index of that value for future use, right? Because we are storing every data, so we can check if that data can be used to find our answer or to find the target. So it is giving me the wrong answer. Okay, it should be something like this. Okay, the target minus nums I is inside the mp. So now let's run it. Okay, so here you can see it got accepted. So the overall concept is that we had two unknowns and we converted two unknowns to the one unknowns, and another unknown is finding by iterating over the array, and one of the unknown we are storing in the map, so we can use that for finding the target. Okay, so basically we are using map to memorize the values. Okay, because in the array we cannot do it, or it will take again n square, but with the help of map we can take log n, which will give you n log n. Okay, so this is easy problem from the lead code, but the concept of this time complexity with the n log n, it may be complicated for the first time, but if you try to dry run on different examples, different inputs, it is really easy. Okay, so try it yourself, so you will be able to understand. So in the next video we are going to solve more problems. Until then, thank you everyone, have a nice day.